feet. That's how long each of Therizinosaurus's claws measured, longer than a baseball bat and the largest of any land animal in Earth's history. When scientists discovered these massive weapons in 1948, they immediately assumed they belonged to a super predator that could slice through anything. Museums created terrifying displays showing this beast as a killing machine. But here's the incredible truth. Those record-breaking claws were used for something completely different. This gentle giant was actually using them to delicately harvest leaves from the tallest trees like a massive prehistoric gardener. For decades, paleontologists were completely wrong about one of the most famous dinosaurs ever discovered. And it took a single bone discovery to shatter everything they thought they knew. When those first massive claws emerged from Mongolia's Gobi Desert in 1948, scientists made what seemed like a logical assumption. Claws this enormous could only belong to a super predator, something that could tear apart any creature unfortunate enough to cross its path. Museums around the world created displays showing this terrifying beast as the ultimate killing machine, complete with razor-sharp talons and a hunger for flesh. But by the 1960s and 1970s, strange bone fragments started appearing that didn't match the predator narrative at all. These weren't the sleek, speed-built bones you'd expect from a hunter. Instead, paleontologists found a backward-tilted pelvis completely unlike any known carnivore. 4 weight-bearing toes instead of the typical 3 that predators used for balance and agility, and robust arm bones, built for raw strength rather than swift, deadly strikes. The evidence was pointing towards something entirely different, yet the scientific community held on to their original interpretation. Paleontologist Anatoly Rojdestvensky made the first major challenge to conventional thinking in 1970. He suggested that these claws might have been used for opening termite mounds or collecting fruit from trees, marking the first time anyone seriously questioned whether this creature was actually a predator. Still, most scientists weren't ready to abandon 4 decades of established thinking based on incomplete remains. Then came the breakthrough discoveries that changed everything. More complete skeletal remains revealed a barrel-shaped torso designed for processing massive amounts of vegetation, long neck vertebrae that would allow reaching high into trees, and most shocking of all, leaf-shaped teeth specifically designed for grinding plant matter. These weren't the sharp serrated teeth of a meat eater, but the flat grinding surfaces of an herbivore. The scientific community resisted accepting that the largest claws in land animal history belonged to a plant eater. The discovery of related species like Erlikosaurus provided the missing puzzle pieces. This creature revealed small peg-like teeth and a toothless bill-like structure similar to a bird's beak, confirming the herbivorous lifestyle across the entire group. When Bapiosaurus was discovered covered with feathers, it cemented these creatures' place among theropod dinosaurs while proving their peaceful nature. The combination of dental evidence, skeletal structure, and comparative anatomy finally proved Therizinosaurus was a plant eater, completely rewriting paleontological understanding. Those record-breaking claws weren't weapons at all, but highly specialized tools designed for an entirely different purpose that would revolutionize how we understand prehistoric ecosystems. The very claws that scientists once believed could slice through bone were actually used with the delicate precision of a master gardener tending the tallest trees on Earth. This posed one of paleontology's greatest mysteries. How could a dinosaur equipped with such massive razor-sharp weapons use them to harvest vegetation so gently rather than tear everything apart? It was a biomechanical puzzle that seemed impossible to solve until researchers began analyzing the complex design of these remarkable structures. The claws themselves reveal an engineering marvel perfectly adapted for controlled plant manipulation. Each claw featured stiffened keratin sheaths that provided durability while maintaining flexibility, reinforced bone cores that could withstand tremendous forces without breaking, and specialized muscle attachment points that delivered both raw strength and surprising control. These weren't crude weapons, but precision instruments designed for a specific purpose that had nothing to do with killing. Biomechanical studies show these claws functioned exactly like biological cranes, allowing Therizinosaurus to reach vegetation 13 to 16 feet above ground level. Modern ground sloths provide the closest comparison to this feeding strategy, though none approach the scale of Therizinosaurus operations. The feeding process involved using the claws to hook and pull down flexible branches, bringing high canopy foliage within reach of the creature's specialized teeth. Each movement required precise control to strip leaves with careful motions that avoided damaging the branch structure or destroying the very food source the animal depended on. This high-browsing strategy provided an enormous evolutionary advantage that explains how such a massive herbivore could thrive in competitive prehistoric ecosystems. While other plant eaters fought over limited ground-level vegetation, Therizinosaurus had exclusive access to an untapped food source in the forest canopy. The thick forests of the Late Cretaceous offered abundant high-growing plants that remained completely unavailable to ground-level browsers, effectively eliminating competition for this crucial resource. The robust arm structure and three-fingered hands provided the stability and dexterity essential for controlled vegetation manipulation, rather than the slashing attacks typical of other theropods. These powerful arms could support the animal's massive weight while reaching upward, and the three-fingered configuration offered superior grip strength compared to the two-fingered hands of most predatory dinosaurs. The muscle attachments show clear adaptations for pulling motions rather than striking or tearing actions. Functional analyses reveal the claws were most effective for hook and pull operations rather than digging or slashing movements. The curved shape and reinforced structure made them perfect for grasping branches and drawing them downward in smooth, controlled arcs. This feeding method transformed Therizinosaurus into nature's most effective tall tree harvester, capable of processing enormous quantities of high-quality vegetation that other herbivores simply couldn't reach. The combination of reach strength and precision created a feeding system that would prove crucial for survival in an ecosystem filled with deadly predators. "70 million years ago, the forests of ancient Mongolia were home to some of the most dangerous predators that ever lived, yet a slow-moving, plant-eating giant managed to thrive among them. The Nemegt Formation created a landscape of lush river systems and dense woodlands where seasonal monsoons brought hot, rainy summers followed by cold, dry winters. These extensive forests, dominated by towering Araucaria trees, supported a complex community of dinosaurs that included some of the most formidable hunters in Earth's history. Talk about a bad place to live if you were a herbivore. The apex predator Tarbosaurus ruled this ecosystem, standing 12 feet tall with bone-crushing jaws that could snap through virtually anything. Swift Alioramus prowled the forest edges, while the unpredictable giant Gigantoraptor added another layer of danger to an already threatening environment. These predators shared the same rivers, forests, and feeding grounds as Therizinosaurus, creating a survival paradox that seems impossible to solve. How could a massive, slow-moving herbivore coexist with such deadly carnivores? Therizinosaurus developed a survival strategy that combined intimidation with strategic habitat use. Standing 16 to 20 feet tall, this giant used its enormous size as a psychological weapon, presenting a formidable silhouette that gave even Tarbosaurus pause. When confronted by predators, Therizinosaurus positioned itself near dense vegetation, ready to disappear into the thick forest cover where larger predators couldn't follow effectively. Those enormous claws served a dual purpose, primarily to reach high vegetation, but they could instantly become terrifying defensive weapons when threatened. A single, well-aimed swipe could generate enough impact force to break bone, making even top predators like Tarbosaurus think twice before attacking. The powerful forelimb muscles originally evolved for precise control during foraging could just as easily deliver formidable defensive strikes. The ecosystem's carrying capacity allowed Therizinosaurus to reduce competition through ecological niche partitioning. While ground-level herbivores like Saurolophus and Nemegtosaurus competed for low-growing plants, Therizinosaurus accessed the untapped canopy resources that other herbivores simply couldn't reach. This feeding strategy eliminated direct competition and reduced the need to venture into open areas where predators typically hunted. Environmental advantages further supported this survival approach. Seasonal flooding created temporary safe zones where predators avoided waterlogged terrain, while the dense forest cover provided concealment opportunities throughout the year. The abundant high canopy vegetation meant Therizinosaurus could remain in relatively protected areas while still accessing quality food sources. This survival strategy combined habitat specialization, defensive capabilities, and ecological niche partitioning to successfully coexist with apex predators. Rather than competing directly with other theropods through speed or aggression, the Therizinosaurus chose a completely different evolutionary path that prioritized adaptation over confrontation. In the family tree of theropod dinosaurs, Therizinosaurus represents one of evolution's most remarkable plot twists, a creature that chose cooperation with nature over domination. Both Therizinosaurus and the famous Tyrannosaurus rex shared common ancestors within the theropoda clade, yet their evolutionary paths diverged dramatically. While T-Rex evolved into the ultimate apex predator with bone-crushing jaws and razor-sharp teeth, Therizinosaurus took a completely different route that led to peaceful coexistence with its environment. The evolutionary shift from carnivory to herbivory within the theropod lineage required profound anatomical changes that transformed the entire body of the animal. Therizinosaurus developed a highly specialized digestive system capable of breaking down tough plant fibers, along with leaf-shaped teeth adapted for grinding vegetation instead of tearing flesh. Its jaw structure also evolved to prioritize crushing plant matter rather than delivering killing bites. To complete this entirely new herbivorous lifestyle, Therizinosaurus possessed long, curved claws not designed for killing, but for reaching and manipulating vegetation with remarkable precision, an ideal biological tool for a creature that had abandoned its predatory instincts. This evolutionary strategy proved remarkably successful across multiple continents and time periods. The fossil record reveals the rhizinosaurid presence in Asia, North America, and possibly other regions, showcasing their adaptability to diverse environments and climates. Their widespread distribution demonstrates the effectiveness of their herbivorous lifestyle and specialized adaptations, allowing them to flourish in ecosystems that would have been hostile to less adaptable creatures. The broader implications reveal a brilliant evolutionary strategy that avoided direct competition entirely. While other theropods engaged in intense battles for limited prey resources, the Therizinosaurus accessed an abundant renewable food source with minimal competition from other herbivores. This approach allowed peaceful coexistence with apex predators like Tarbosaurus, relying on size, defensive capabilities, and unique feeding adaptations rather than aggressive confrontation. The Therizinosaurus's peaceful approach to survival represents a triumph of evolutionary innovation that challenges our understanding of what made dinosaurs successful. By choosing adaptation over aggression and specialization over generalization, this gentle giant proved that evolutionary success could be achieved through cooperation with natural systems rather than domination over them. This discovery fundamentally changed our understanding of dinosaur diversity and revealed the multiple pathways that led to evolutionary triumph in Earth's most competitive prehistoric ecosystems. The Therizinosaurus proves that evolution's greatest successes often come not from being the strongest or fastest, but from finding entirely new ways to thrive. This gentle giant story transforms our understanding of what it meant to be a successful dinosaur in Earth's most competitive ecosystems, while other theropods battled for dominance through brute force and predatory skills. Therizinosaurus achieved triumph through peaceful innovation and specialized adaptation. The legacy of this remarkable creature challenges us to reconsider our assumptions about prehistoric life and the diverse strategies that led to evolutionary success throughout Earth's history.